Okay, so I'm going to do this transformed graph. This is the function. I'll put it back on this screen. All right, so we have a test coming up when? Thursday. And on your test, when you're working the transformations, it'll ask for you to write your transformations. And I'm looking for something like, what I'm about to write down right here is what I would be looking for on your paper, okay? I'd be looking for, first of all, that they're in the correct order. Mm-hmm. Bless you. Can you do what? I'm not sure what you're asking me. Are you asking me about this one I'm about to write down? Or asking me for something later? Okay, ask me again later. At that particular time. Yes, sir. All the transformations. So here's what I'm looking for in your test. I'd be looking for that you need to go to the left 2 first. That -1 in front of the x means you're reflecting over y. Then times 3 is next, so that's a stretch 3. And then the -y is last, so down, or the -1, so that's down 1. Okay, and that is the proper order. Yes, ma'am. Well, what do you think you would write instead? Would it like times 3? Yeah, that's fine. Because I know what you mean. Yeah, I think I would take times 3. And let's go over again real quickly. Like, let's say it's test day and you don't have your notes with you. How you could remember what order to do your transformations. Okay, there's 2 Jedi mind tricks for that. You can remember that it's like order of operations, PEMDAS. Okay, so if you're taking care of parentheses first, now this particular problem doesn't have parentheses. What's acting like the grouping symbol here? The square root. So you would look under there first, okay? So you look under there and you are going to take care of the -x plus 2. Since there's 2 things going on under there, you will always do left to right first, no matter what's going on. You're always doing horizontal first. So in that case, we're taking care of the plus 2, which is where I have that left 2 from, because insiders lie. And the -x, real quickly, if you can't remember which way that goes, just to give yourself an x value, like on the graph. Say, okay, well, what if my x value was 2? If I'm taking the negative of it, what does that mean it's going to do? It's going to come over here. It's going to flip over the y-axis, okay? And so that way you can give yourself just a little memory tip for figuring out which one that is. And so that's where the over y comes from. And then you take care of multiplication next, which is the times 3. So a stretch by 3. And you take care of addition or subtraction last, which is that -1, so down 1. You can also think about it as going kind of like from the inside out. You're taking care of the things closest to the x first. So in this case, that is the negative and the plus 2. But you would have to remember to do the horizontal first. So that would be the left 2 and then the reflection. The next closest thing to the x is the times 3, and the farthest thing from the x is the -1. So either remember order of operations or tell yourself you're working from the inside out, the thing closest to the x, and then you're working your way to the thing that's farthest away. So here's how we actually do this transformation. The parent graph is absolute value. So that's 0, 0, 1, 1, and 4, 2, because 4 is the easiest thing to take the square root of. Right, so I'll do this one transformation at a time. The first one is left 2. That one's easy. Each of those points goes to the left 2 places. And now I'm at the red thing, so I did that in red. I'll do over y with green. So here's what that means to do over y. This point at -2, 0, it's 2 to the left of y. I need to move it 2 to the right of y. And not your shifted y. Like, I just shifted this point, and so now I have this, like, transformed y-axis. You're not reflecting it there. You're reflecting it over the original y-axis. So this is not where the reflection occurs. And then this point at -1, 1, it's 1 to the left of y. I need it 1 to the right. This point is 2 to the right of y. I need it 2 to the left. And so that's my reflection over y right there. the stretch by 3, your x stays the same, your y value gets multiplied by 3. So I'm looking at the green points. This green point has a y value of 2. So when I multiply it by 3, that gives me 6. So that point goes up here. This green point, 1, 1, when I multiply that by 3, it becomes 3. So it's now at 1, 3. And then 0, this 2 point, the 0 y value stays the same. And because I ran out of colors, you know what time it's for? Teal. So now everything just comes down 1. And your initial point is at 2, negative 1. So that's the final answer right there. Okay? Yes, ma'am.
For the test, will we have to remember the points of each parent?
Yes, you'll have to remember the points of each parent. And they're really, most of them are where x is negative 1, 0, and 1. The square root and the cube root are the ones that you will have to, and just think about, well, what's easy to take the square root of? 0, 1, and 4 for x values, right? And that'll help jog your memory about what that is all about. So we did our warm-up. I'm going to take any homework questions, go over your skill check. We have a new skill check for today and a new lesson. The good news about the new lesson is it's just one problem.
Is it on the test?
Mm-hmm. And it's my favorite lesson of the whole unit. So this is the last lesson for the unit. It's the last new material. The last several days, what we've done is we've been given an equation, and we read it, like we read the important parts of it, and we do the transformed graph from the equation, just like we did on the warm-up. But now we're going the opposite direction. We have the graph. We're going to pick off the important pieces of information, and we're going to use that to create the equation that goes with the graph. So these are the basic steps for what we're going to do today. We're going to first figure out the general equation for whatever the parent function is on the graph. So you have to be able to recognize the form of the graph and be able to know the parent function. We're going to plug in a special point, quote unquote, for h and k. And if you remember last week, one of our homeworks, for those of us who do the homework, is we identified the special points for the different shapes of graphs. For example, quadratic or parabolas and absolute value have this special point. What did we call it? The vertex, right? Absolute value has this special point. Do you remember what we called it? Initial point, right? And then cubics and cube root, that's not, you know what I'm going for there. That's not exactly, that's terrible. Hold on, sorry. Cube root have this special point, and do you remember what we called that one? An inflection point, right? So for this step 2, when I say plug in the special point for HK, it depends which shape that you're looking at, but it's the vertex for those, the initial point for those, or the inflection point for the cubics. And for when we get to step 3, when I say plug in a pretty point for x and y, I generally mean find some place where the graph crosses an integer value, like it's 2, 3, or 1, 5. It makes your math easier and more accurate. Most of the time, at least for your homework, the point's already identified for you. And so if the point's identified for you, it might not be an integer, it might be a fraction, but you know it works because that work's already been done for you. But if you're just finding your own point by yourself, it's best to try and find a point that's integers. And once we plug in, and this plug in a pretty point, that's going to go in for the x and y in the general form. We'll solve for a. Remember, the a is going to represent your stretch or your compression factor. And then 5, you'll take that a value, the h and the k, and plug them back into step 1. And that final point, that final step is your actual equation for the graph. So that very first step, write the general equation. I have all of those listed for you right here on the notes. Okay? We've just taken the parent function, like for example for square, the basic function is this. But once you add in an H to represent any kind of horizontal translation, a K to represent any vertical, and then an A value to represent stretch or compression, this is where we get this general form. And that's what we're using to find our equation. So on the one example problem that you have on your notes, we have this graph. Okay, this is just general form again. I put this up here because your homework has that form. It's just what we already talked about. The first thing we need to do is recognize the shape of this and which parent function it is. And what is this one? Absolute value, right? So we start off just recognizing that the parent function is y equals absolute value of x. The general form, okay, from the list on your notes, which you will need memorized by Thursday, but once you figure out the pattern, it's not really a lot to memorize. You just take the general form, you slap an A out front, you do a minus H as for insiders lie, inside whatever your grouping symbol is. In this case, it happens to be the absolute value bars. And then you slap a plus K at the end. Okay, so that pattern is the same for each one, whichever you're working with. Remember, our goal is to solve for A, so we need numbers in every other variable spot. For HK, the special point for this graph is this vertex right here, 1, 2. Okay, so my vertex, bless you, is going in for HK, and it's 1, 2. So what does this mean? It means for H, I'm plugging in what? And for K, I'll be plugging in 2. And then for XY, I need a pretty point. There are 2 points indicated, these solid points, a left and a right point. It does not matter which one I choose. As long as my math is good, I'll get to the same answer. So do you want the left point or the right point? The right point? Okay. So that's 5, 0. And that's going in for my XY. So I will plug in those things to the general form. So my general form is y equals a times the absolute value of x minus h plus k. So just going left to right, what am I plugging in for y? 0. What am I plugging in for a? Nothing, right? Because I'm trying to solve for a. So don't force it. There's nothing going in for a. Okay, so don't overthink or confuse yourself. A stays a because we're trying to solve for a. The absolute value, what's going in for x? 5 minus whatever h is, which is 1. What if h had been a negative 1? It'd become positive. This minus stays the same no matter what. That represents your insiders lie. So it would have been minus a negative 1, which would have become plus plus. So 5 minus 1, absolute value, plus k, which is 2. All right? And if this had been a negative 2, you would have had plus a negative 2. How do you rewrite plus a negative 2? Minus, right? Minus 2. So then after this part, it's kind of like it's an order of operations now. You have to shift your brain back to just solving this regular linear equation, right? Following your order of operations. So you simplify inside the absolute value. 5 minus 1 is 4. So we're solving for a now. What is the absolute value of 4? 4. So this becomes 4a plus 2. Subtract 2 to both sides. Divide by 4. A is negative half. But that's not the final answer, right? So the very last step is you're taking your a, your h, and your k values, and you're plugging them back into the general form from earlier in the problem. So plug a, h, and k. into the general form. So that gives me y equals a, which is negative 1/2. The absolute value of x minus h, which was 1, plus k, which was 2. Yep. Excuse me.
Are there points?
No. But why would you think that? You would have a different x and y, but if the math, once you work out the math, they'd come up to exactly the same. So for like example, if I tried to do this with -3, 0, what would happen is at this point in the problem, I'd get a -4. But when I take the absolute value of it, it's still a +4. And then all the rest of the math would work out. Does that make sense? So that's a good question. It does not matter which point you use. As long as your math is good, you get the same answer. By the way, this represented all the steps of the math. I don't know. And a couple things I want to talk about here. There's some self-checks you can do, right? You would look at your equation and say, okay, does it make sense that this equation represents the graph? For example, do I have a vertex at 1, 2? Yeah. This is a compression. The y values were cut by half. Does it seem like the graph is sort of fatter than the parent function? And then this negative a value means I had to reflect over x. Did that happen? Yeah. So you can do those little self-checks as well. Use all your context clues to check on your answer and see how you did. All right? So any questions about that? All right. We are done for the day.